So here we are today, the third stop of the Residfield Roadshow. I'm here at Belfast with my colleagues. We're going to be live streaming fairly shortly a fire test. And what we're testing today is a cavity barrier scenario in this building. And what that will be is a scenario where a balcony is penetrating through the cavity. We're using the Stubguard, the Sapphire solution, which wraps around and shrouds the arm and thermal brake, and the cavity barriers will be going to the side of that. It's a 2-hour test, and we're looking forward to live streaming that to you shortly. So we're now inside the test lab here, where we'll shortly be putting this furnace door on and then putting it up to the temperature. The test we're doing is the BSEN 1364 Part 6 test, and what we've been looking at here is testing the underside of this cavity barrier. The point and purpose of this is it's like a fire in apartment below, if you like, and it's about stopping the fire spread going through where the balconies are connected back into the building. So you can see here inside the furnace, you'll see here at the top we've got a Stubguard shrouding around that balcony anchor, and that's sandwiched between two non-combustible blocks. The supporting guidance document BSEN 1363 has a temperature curve here based on times. What we're looking at today is the 2-hour test time, which means that inside this furnace, obviously not when I'm in here, the temperature will be getting over 1,000 degrees. We're getting up to approximately 1,060 degrees, and that's to test the underside of this for 2-hour duration. We'll have a look at the data as we go through the test today, but in the meantime, this is a bit of an understanding of what the inside of the furnace is like and how it's being tested at this height here to replicate a cavity scenario. So the door is now going back onto the furnace, and that means that the test can start shortly, and we'll be filming from above so you can see what the activity is. Unfortunately, that's the last we're going to see of the inside until after the test is now done. Test here today with Efectis here. We've got a test starting behind us, is starting with a purge, and shortly the actual fire test will start. Now, you're welcome to ask questions as we go through. We're glad to answer the questions live here today, and we'll be coming backwards and forwards to show you and point out bits to further your knowledge and competency. As we do that, feel free to log into www.sli.do using hashtag #AskAsk, and you can ask your own questions and get them answered live here today from the specialists. So, would you like to introduce yourself on behalf of Efectis?
Yes, so my name is Guillaume Remy, and I'm working in the fire testing department of Efectis UK Ireland, and I will present you today's test here.
Thank you very much, and we're glad to be testing here to BSEN 1364 Part 6. Tell us a little bit about what that standard is, what we're actually testing here.
So this standard is for non-load bearing elements, and we are testing today like a closed cavity like barrier alongside with your safeguard systems. So it's an ad hoc testing. This standard is on the question at the minute, so it's only ad hoc testing, yeah. But we will collect the data and we can see how it's performed with your product.
Thank you very much. And with Stubguard, many of you may be familiar with it. It's a product which has already become popular, and we've done lots of testing previously on this, to this test standard and to others as well. Today what we're testing is two differences from what's often been tested before. And that is, one is that it's a new low carbon anchor, So it's got a slightly thicker thermal break than what would previously have been used. So that's one scenario. That also has been tested previously, but we've also got a slightly different configuration, and this reflects real life testing. So what we're doing is we're testing a proven product, but we're seeing in a different scenario what are the limitations, what are the potential performance differences between that and other scenarios. And we look forward to discussing this a bit later on. The test will be a 2-hour test, but Gilly, what do you expect to happen over the next 2 hours?
So obviously, like, I don't exactly know when it will happen, but at some point we'll expect to reach like some maximum temperature. So it will be above 180 degrees plus the start temperature, so it will be roughly around 200 degrees. We can also expect some failure due to flames going through around your sample. But we'll have to see like if there's any other like unexpected behaviors, obviously. But we'll obviously check for that. Yeah.
So during the next 2 hours, there'll be a temperature increase in line with the standards and what's required. During that process, we'll be measuring the different temperature sensors we've got on there. Tell us a little bit about these sensors and how that will work, Gilly.
Oh, so we install on the specimen internally like some, I would say, Type K thermocouple. We connect that to our acquisition system, so we can display in real-time scenario like what's going on and what we measure on your specimen. So, yeah.
Would you be able to show us a little bit about what's on display on these screens here?
So here, basically, we have an acquisition system. So we just started the test here. So as you can see, we have the temperature increasing. That will be the Type K thermocouple inside the furnace measuring making sure we are following the fire curve. And then in the display over there, we'll measure the maximum temperature on top of your Safeguard product and also on top of the fire barrier on the side of it. And if you want during the test, we can also display the internal thermocouple within your system, within the I-beam or any other thermocouple we have around. Yeah.
Thank you very much. And as we go through the course of the next 2 hours, we will be having a panel discussion shortly with a number of specialists from the UK industry, including the National Fire Chief Council. For those of you who may be new to testing and balcony Stubguard, which is the Sapphire product we're testing today, just a brief explainer. We're testing to 2 hours, 120 minutes. During that period of time, we can basically, there's 180 degrees above ambient, which is what we're looking at as being the temperature being below that point. The Sapphire Stubguard has got various sensors on top. It's got some on the cavity barriers and some within the actual I-beam, the arm or the stub, as you may know it from a balcony component point of view. So we look forward to coming back and having a look at this test data as we go. In the meantime, don't forget to ask your questions, www.sli.do and #ASK. Thank you very much for tuning in. We look forward to furthering your knowledge and competency.
I feel it was not too bad.
So we're now 6 minutes into this test, 6 minutes 22. What you can see is a slight amount of smoke coming through there. The temperature inside the furnace is heating up. A couple of minutes ago it was about 500 degrees. That's continuing to climb. The various sensors are being checked to make sure that they're all correctly displaying information. We'll have a look at the graph in a second on that. In the meantime, keep watching and we'll be back shortly. So I'm going to talk you through now some of these screens here and what we're seeing in terms of data and what the purpose of this is in the test here. So the first one we're looking at here is the curve of fire, the fire curve, and what we can see here is now the inside temperature of that furnace is up to about 750 degrees Celsius. Some of the other temperatures we've got here are showing are showing the other sensors which are attached to both the cavity barrier and the stub guards. So what we've got here, this is a plan view drawing showing the sensors here. So we've got these sensors at the top which are on one of the cavity barriers. They're put at critical junction points because the major thing with fire testing is understanding how things interface with each other, and that's really a really key part of the learning, because fire testing is not about getting a certificate, it's about learning and getting a clear understanding on why things pass and why things fail. By doing so, we can then enhance the safety of buildings. In the stub guard here, the stub guard has two pieces, and I'll show you that in a second, but there's a number of stub guard sensors on the outside. These are the ones you're seeing on top of the furnace when we display that view. Further down we have one which is on the edge of what would be the slab edge in this test scenario, so the back of the shutter. Now inside of the stub guard itself we have the I-beam, or the stub and arm, where the balcony is actually penetrating through the building and taking the forces back to the slab edge. As you can see here, this diagram here shows a green indicative piece of the stub guard. So there's two pieces, as I mentioned. They slide in together and push back into position. And then the orange is the cavity barrier. We've removed this piece here for clarity, and that piece is the stub guard. But what that shows us here is we have three sensors on the web of the I-beam and the two flanges there. The bottom one is obviously the one nearest to the furnace, and that's what we see here on this orange line, which is the one which is increasing in temperature, but it's about 35 degrees. So still well within limits there. So as I mentioned, these are the sensors here. You'll see more of those as we go through. But for now, let's move on to looking at the temperature on the actual stub guard itself. So I mentioned that it's the critical junction points, which are where the sensors are being placed. That's because that's where the maximum learning is going to be, rather than placing them on somewhere which is going to be a fairly safe and low temperature number. So this is things like, for example, where the cavity barrier actually butts into the stub guard itself. And what you're seeing here is a range of different temperature sensors. And again on the actual cavity barrier as well. So understanding where those are is quite critical. The numbers here ranging starting at the ambient temperature of around 15-17 degrees down the bottom here, through up to the top temperature here at the moment on both these graphs, about 47 degrees on this one and about 43 degrees on the other one. So hopefully that gives you a bit of an insight. We're very shortly going to be going to the panel discussion because we're not expecting anything significant to happen right now. If something does happen, we'll be back, but for now, we'll see you on the panel discussion shortly. Don't forget, keep asking those questions. We will briefly take a check of the questions before we go into the panel discussion, and we'll come back later on. Don't forget, ask those questions, www.sli.do and #ASK, ask. Thank you very much, everyone. So thank you very much for everyone who's asked questions so far. We are going to go through and answer a few of these now. In the meantime, keep those questions coming. www.sli.do #ask. So the first question we've got here is, what test is being done? So as we mentioned at the beginning, when we asked Efectis to explain it a bit more detail, we're testing BSEN 1364 Part 6. Now the reason for this is balconies, like many other niche products, don't have specific fire test standards for testing certain balcony components in that scenario. So we take guidance from experts in fire safety and fire testing as to what the best tests to do, because what we want is a consistent test standard in which we can compare different products, different results against the different learnings. So as part of this, that's why BSEN 1364 Part 6 has been chosen, and that's what we're testing against. That is a publicly available document which you can access. So the second question, what are you hoping to happen or not happen to the Stubguard in the next couple of hours? Well, that's a great question. The first and most important thing for us over the next couple of hours is that we learn something. And as part of this, what we're expecting is to see the temperatures to increase and keep rising. Certain sensors will be picking up where there might be weaknesses in perhaps the fitting of a cavity barrier, the interface between a cavity barrier and a Stubguard, or the Stubguard itself. It's a bit of an unknown, obviously, with testing. That's the whole point of testing. And as we go through that, we'll then know a bit more about that and we'll be able to answer further down the line. The third question, what sets Stubguard apart from other fire stopping methods? A great question. I'm going to start by answering that as to kind of really what would you be using without a Stubguard? If you weren't using anything, and that's not obviously a compliant solution as far as we're concerned and as far as many fire engineers would be concerned, is that you'd be using an I-beam going through back into the building, and that would be directly exposed to the heat. Now the furnace temperature is several hundred degrees C, and therefore the actual I-beam, given that steel and metals conduct the heat quite well, would be increasing rapidly in temperature as well. What we're not seeing at the moment in the test results, as we'll look at on the screen in a second, is that rapid rise, because the Stubguard is protecting that. So in terms of what actually sets it apart, it's a pre-manufactured item. It's made in 2 parts, and that minimises the risk of the install being done incorrectly because of the fact that it's being made as a machine product as opposed to being cut on site and put together. So the next question here is, why are the temperatures rising differently between the cavity barrier and the Stubguard? That's a brilliant question. I didn't particularly notice which temperatures they were at. I think from memory it was something like 48 degrees versus 44, and then the majority of the sensors are much lower than that, around 20 degrees in the Stubguard. Now, the reason for that there's several parts to that question. One is the fact that the sensor placement and where that is will make a massive difference. So that's the first part. The second part is the quality of how things are put together. And the third one is the actual product material performance. There's many other reasons as well, but they're some of the 3 key areas. So the area of which the sensor is in, how critical that junction point is and so on, the workmanship, if you like, and then the product itself. So they're the main drivers to that. Could you please show us what is actually being tested? Great question. In terms of what's being tested, we'll put a link on the chat to what the Stubguard is, so you can have a little bit look at the information on the Sapphire website. But what you can see is being tested is actually a shroud around an I-beam. So the I-beam is where the balcony connection goes back into the building. Beside that, you've got the cavity barriers, and the point of that really is stopping the transfer of heat, so the integrity and the insulation between what would be one apartment and another apartment. So the Stubguard, you can see, is the one which has got lots and lots of green sensors on top of it. When we cut back to the other camera view of the top there, you can see the edge of a cavity barrier there, but sandwiched between those two concrete slabs. So if you think about the right-hand slab there on the top as being the floor slab of a building, and you think about the left-hand one being the external skin, the external envelope, the facade, whatever you want to call it. This is a closed state. We looked at that with Efectis at the beginning of this test. It's a closed state, which means it's not rain screen cladding or a system like that, which has got a ventilation there. And in between there, you've got the cavity barrier at the top, which is that compartmentation, and below that would be where you'd normally got the installation sign on a building. So that's what we're seeing here in this fire test so far. We'll just head back to the other questions. So, last question for now. Are there any specific regulations or standards that pertain to the use of Stubguard in residential construction? How does this test align with those requirements? So, great question. Referring to one of the other questions fairly similar to that, is that there's multiple different standards which relate to balconies. There's multiple different test standards which relate to balconies, not just from a fire safety point of view, but things like, for example, glass on balustrades. Each one of those has a specific test standard. However, the tests have to be generic enough to be able to test a range of different products and continually compare between different types of products. So, for example, if you're testing a balustrade internally versus a balustrade externally for impact or line load and so on, those tests have to be consistent between one manufacturer and another to be able to understand the data between one manufacturer's product and another. It's exactly the same with fire testing. Fire testing has various different aspects to it, obviously, and with the standards, this is one of those scenarios which can be tested. This same standard could be used for many different products, but from a balcony point of view, because it doesn't have any specific balcony standards in relation to testing where a balcony penetration is going back into the building, this is the closest one to that with an official test. And that's why it's being used here today in that scenario. So for now, it looks like that's all the questions which have come in. If you wish to ask a question yourself, please go to www.sli.do. In the meantime, goodbye from me, and we'll be cutting shortly to a panel discussion. Thank you very much.
Then I can go upstairs now?
Yeah, sure.
Thank you.
While this panel recording is going on, there's a live streamed fire test going on in an Efectis test lab in Belfast, and we may need to break off the panel at some point if anything particularly interesting happens. So apologies in advance if that does have to happen. But in the meantime, welcome, and we're glad to have a very knowledgeable panel here with us today. I'm going to start off, Tina, perhaps if you could start off by introducing yourself as to who you are and a little bit about your background, please.
Hello there, Tina Jolliffe. I'm an insurance broker. I've been in the industry for 33 years. We specialise in effectively the fire sector and have obviously developed a product, particularly around professional indemnity, where the construction and obviously fire experts have had particular difficulties with.
Thank you, Tina. Ashley.
Yes, hello. My name's Ashley Mather. I'm a fire engineer at NFCC. I've been here for the last 12 months or so and involved in a number of work streams, including some of the ADB reviews, which obviously include the balcony testing that I think's been going on at the same time. Just prior to this, I worked as a fire safety regulator at Sapphire for 10 years and went my way up to an engineer there as well, becoming a bit more involved in the science behind it all.
Thank you, Ashley. Mark.
Yeah, hi, Mark Humphries from Merry Miller. I'm a director that heads up our building safety team, which includes our fire engineering team. And we predominantly are working in the sector at the moment, looking at external walls, assisting our clients with their external risk assessments, and also assisting the government as well. Homes England, we've been appointed as one of their primary PAS assessors to PAS assess and audit PAS assessments in line with the new funding.
Thank you very much. So we should surely have Efectis fire engineer joining us as well. But in the meantime, let's kick the conversation off with looking at kind of the primary purpose of what we're talking about today here, fire testing. So perhaps Ashley, a question for you. From the kind of service aspect and from the broader picture, what do you see as the primary purpose and benefits of fire testing, particularly in relation to materials and architectural design and the way those products go together?
Well, I think I suppose the real starting point of it all is to ultimately ensure we can, whatever we build and whatever we construct, that we end up with a safe building. A building that's going to keep people safe inside, let them time to get out, and hopefully stand up. But I think, and that's the ideal world, and that's what it should be. But I think we have to be cognizant of the realities that actually a lot of fire testing is there. We want to understand how buildings are going to perform and fire test in the event of a fire and how they hold up. And fire testing gives us a means of evaluating that and comparing different products against each other. And I think whether you are designing a building and going down a prescriptive based route in terms of design, you're following some rules, or whether you're going down a performance based route involving fire engineering, you need to understand how that building is going to hold up in the event of a fire. Is it going to stay safe? And there's a lot of fire testing. It can be, it can be how long is it going to continue to do his job? How long, how combustible is it? There's many aspects to fire testing and what you're actually looking at monitoring. But so at the heart of it all, it's down to getting a safe building out of it, and you need to know what's going into your building, and the testing helps us understand that.
So it's a great point you make there, Ashley. And Tina, have you got anything to add to that particular point?
Yeah, I think there's also the kind of from the insurance perspective, we've got to bear in mind there's a lot of different insurers involved in a process in a building. And I think sometimes this is forgotten about from the point of view that obviously the owner, the responsible person, should we call them that as well, the asset itself, we obviously have the liability and the safety side, and then obviously we're going all the way through to the start, the construction, to actually the end. If something does go wrong from the PI perspective, professional indemnity. So I think the importance is actually having that traceability on the test, having that defensibility for whichever part of the insurance, or if it gets called upon, I think sometimes gets lost. And I think sometimes you've got to bear in mind insurers work in silos. They don't all talk to each other. People have different insurance policies. We have lots of construction, lots of parties involved in, obviously, a development. So, I think that's got to be taken into consideration. And this is where the fire testing really will come into help, that sort of, those sorts of discussions.
Yeah, so interesting points there as well. And Mark, particularly, I know you're particularly involved in the refurbing and renovating high-rise, high-risk buildings.
The other part of our business also deals project managers new build, and our fire engineers get involved in the early refurb stages throughout new build as well. I think I'll add on to Tina's point. Really, it's about the golden thread of information that flows through that project and enables our clients, when the construction period is finished, to have the requisite information they need to prove their building safe. Now, for me, it's particularly important where we're designing buildings that maybe depart slightly from the approved document ADB, where we're looking for fire engineered solutions to justify, intricate design, maybe not open plan flats, for example, charging points within buildings. Ashley, you're probably acutely aware, as am I, the risks associated with electric charging points, scooters and wheelchairs in buildings. Especially in premises that are designed as maybe extra care or dementia care, where the wheelchair charging is needed. But the requirements, the other requirements in terms of dementia requirements, you require sort of open planned flats as much as possible, so it's less confusing. Sort of conflicts with ADB in terms of fire compartmentation. So fire engineered solutions are needed, and that's where, for me, testing is key, because more often than not, when you look at a fire strategy and you start to technically review it, the justifications for that strategy are sometimes based on an educated opinion rather than scientific fact. And I think we have to be prepared, if we don't have the test data to fully explain a departure from ADB, that we are prepared to go and get that test data and test it specifically for that environment and that construction build-up. Otherwise, unfortunately, when it's retrospectively peer reviewed, which it will be throughout the building's life cycle, there will be questions, technically from us, and I'm sure Tina, from an insurance perspective as well. The attitude and the aptitude for risk at the moment is very low. So we have to do whatever we can to make sure that whatever we do can't be peer reviewed in a negative way in the future.
Absolutely. I think certainly from our point of view, from a balcony point of view, we've done testing for many years. Fire testing has happened a lot more since Grenfell, obviously. But in essence, testing as a general principle is about proving what you've worked out, or engineering judgments which have been made in the offices from our point of view as a product manufacturer. But it's more about exploring both what's known and also proving that, also what's unknown, and actually unraveling that, because some tests do work very differently. We may find that with the test happening in Belfast now, that they may come out with a different set of results. But Konstantinos, what's your thoughts on this first question around primary purpose of fire testing?
So, first of all, I would like to thank you about this invitation. In any case, fire tests have been developed for providing necessary data. That was a primary focus of fire tests. So, overview of products and systems under specified conditions. We have some information we need to consider, and therefore we came up with standardized test methods or ad hoc test methods. This is the information that we need to consider, first of all, about the fire testing. On the first ones, we may have designed methods which are based on previous knowledge of many similar products, appropriate fire scenarios covering real life or similar to real life scenarios, while on the second one, on ad hoc testing, we may design different scenarios which are more project related. This is related also to what Mark explained earlier about many projects. We can also design fire scenarios, fire tests for project related focus. In any case, how we use this data is of significant importance. All fire tests cover, first of all, cover materials, which we're talking about fire behavior of specified materials, construction materials in general, in fire conditions. And then from this, let's say, limitation, having only the material, we go further and we test systems. In fire tests, testing systems, we come up with data, benchmarking data, how the products are linked together. And that's the main purpose of having the fire test. Now, how we select materials, amend the design, Mark talked about fire strategies and everything, is something else. But the fire testing primary focus is provide data, sufficient data, in order to use them, professionals, practitioners with high competency, to use them properly. And that's the main focus of fire testing.
Ashley, you just picking up on one of the points you made is when you were talking, you talked about the looking at how it underpins the overall safety and so on. What are your thoughts on, or could you elaborate a bit about how fire testing underpins building safety?
Yeah, so I suppose Konstantinos mentioned obviously just getting that data, I suppose to support the design. I think obviously when you just kind of follow this through, when it comes to I suppose it's the selection of, once you understand what you need to achieve, the fire testing, I suppose, fire testing allows designers to select products that are appropriate and safe and suitable to be used in their building, and actually how those products relate to the fire test is key, and which of the fire tests are applicable to the products. I suppose it covers all sorts of options. So instead, we mentioned, if we start talking about elements of structure, so the building blocks of the building, and that's where these would probably fall under that. So we start looking at, their ability to, maintain load bearing capacity, prevent smoke of fire, and prevent transfer of heat. I suppose that's where our classic 30 minutes fire resistance, 60 minutes fire resistance comes from, and that's just one aspect of what fire testing is looking at, the building blocks of the building. We then start looking at everything that you put in the building. So you might start looking at the combustibility ratings. That's particularly relevant when we start looking at balconies. How burny is the thing that's going to kind of go on the side of the building? But then you look at any component to a system that's designed to kind of work and protect people in that building. You look at fire doors, that they are systems made up of components. You could look at products, the components in isolation, self-closures. What do tests look like for that in terms of, that's got to work in fire conditions. So there are, I would like to put a number of the amount of kind of products that are out there that we expect to perform in the event of a fire. There will be very, a massive amount of specific tests that have been hopefully designed to capture how they will perform, to give us that assurance when those products finally end up in the building. And none of this takes away from the fire engineer designer's job to make sure these products are going to work together. But these are, we go right down to the real building blocks of the building, the very small parts, right up to how they work together. And these tests factor in at every step along the way.
Yeah, so it's interesting you referenced both the product testing, but also the way they're configured and whether they're common components and so on, interfacing. But I guess this is kind of where the whole aspect of risk and understanding risk sits. Tina, be hard to have somebody on the panel from the insurance background without talking about the word risk. What are your thoughts on this particular topic?
I mean, this is some of the problems that the insurance industry are having, understanding and being educated. And I'll be absolutely honest with you, cladding, as Mark said, is one of the biggest hurdles, and actually huge amounts of work has been done on cladding if we just use it from within the industry. And that information needs to be given to the insurers. So, I'll be quite honest, we set about educating insurers. So let's look at PAS 9980 as far as cladding is concerned. You know, we have actually sat a load of insurers in a room to explain the code, to explain best practice. And I think this is where the risk element, as you've quite rightly said, the good things are happening with the industry. It's ensuring that the industry is explaining it, to be quite frank, in layman's terms, why, you know, why this is good, why this will work, why these components will work together and make it safer, make, as far as the asset is concerned, better protected. As far as liability is concerned, you know, it will actually save lives. So risk has to be, in some respects, analysed or try and translate it into insurers to make them see that actually risk is being mitigated and how it is being mitigated.
So, Mark, no doubt you're involved in the initial stages of planning construction projects, whether they be new build or refurb. But what's your thoughts around that kind of the role of fire testing and actually choosing the right products and reducing risk and mitigating risk from an early stage?
Yeah, I think the point that Ashley made about you got to understand that components tested are tested in isolation, and if you are pulling different components together and utilizing them in a way that sits outside of those test parameters, that you might have to then get it retested to understand how they behave together as a system. Doors is an excellent example, as Ashley stated. You know, doors will be tested to a certain standard in a certain wall type, fixed in a certain way. And more often than not, to mitigate the risk, what we're finding is contractors are now using sort of pre-hung door sets because they are made by, you know, the supplier. They are pre-hung in the factory. You just fix the door in line with their specification, and therefore the door is then certified. From my perspective, within the sort of new build construction industry, at the moment, it's only really suppliers such as yourselves who are being proactive with testing, because obviously you've got big R&D programs, and a balcony system can be tested as a system. I think as we depart from that, where we have seen testing carried out within the sort of new build sector is really not proactive. It's reactionary to an issue that's been pulled up on site. And I'll give you an example. So we had a scheme where the developer was using perforated lintels above flat front entrance doors, and the plasterboard was stuck onto the perforated lintel, and the fire engineer stated, well, that plasterboard's not mechanically fixed. In the event of a fire, it could fall off, and then the perforated lintel would allow smoke to egress into the common areas, which forms part of the protected escape route. And that was a standard construction detail, and is a standard construction detail that's utilised across the industry. But as a result of that, the developer had to go and get a full-scale test done of that construction build-up to prove that it was safe. If that had been done sort of in the early REBA stages, we wouldn't have had a delay to completion on site. I think it's probably gonna become more proactive, and that's mainly because fire engineers are now heavily involved in the early REBA stages, whereas I think before they probably weren't. You know, I can tell you they weren't. You know, schemes are drawn. It's only really when you got to REBA 4 that the fire engineers started to build up fire strategies and understand, but now they're consulted right from the off, because people understand the financial implications of making a mistake, a fire-related mistake, can cost you hundreds of thousands of pounds. Even when the building's completed, you know, these buildings will be retrospectively looked at throughout their life cycle, and the contractor's now liable for 16 years lane defects and 30 years under negligence. So they can't afford to sort of nonchalantly put fire aside and tackle it the same way that we always have. So yeah, for me, it's about making sure that the components you're using have been tested together as a system. And if you are going to sort of move away from tested systems and install components separately and create your own system, that the fire engineer has reviewed that properly, and if necessary, you've had it tested to make sure it works together.
Quite a full answer there, Mark, and I'm going to pick out a couple of bits if you like to talk through in detail. One of those is you mentioned about doing more work up front. Do you think the gateway, particularly the initial gateway, are actually going to make a big difference to that process, in particularly in residential construction, high risk buildings, obviously?
To be honest, because of the attitude to risk, I don't think you're going to find many contractors trying to make a rod for their own back and designing buildings that require substantial testing to prove that they, there's nothing within ADB that says this is safe, so we have to go and test it and create a fire engineering solution. I can't see that happening because of the delay and the potential cost implications. So I think what we're going to see is construction types that are built in a way that takes fire safety into consideration right from the off. So, we're going to see no combustible components within walls. We're going to see no combustible attachments to walls. We're going to see, robust construction types, RC frame. People are not going to depart away from those construction types, I don't think, unless they have to, because of the risk involved with doing that from a fire safety perspective. And that's personally where I think it's going to go, unless you're in a particularly constrained site which requires a different method of construction. I think the industry will standardize its construction types to make them less, to make them more risk averse in terms of fire safety.
Yeah, sure. So do any of you have any comments on that particular stage, or should we move the conversation on a little bit?
Can move on.
So the other part of what you mentioned there, Mark, was about the kind of longer term liability and so on. A question for all of you really, but in terms of the long-term benefits of tests and more regular testing and so on, do you think fire testing has a role in making sure that when things are discovered, buildings are kept safe and so on into the future, or what's Constantine, to start us off on this question?
Yeah, first of all, I would like to mention that fire testing is not a panacea for any issues with regards to fire safety. However, fire testing is a great tool. It's a great tool that we currently have in order to design properly and avoid any design cost or insurance implication that previous speakers talked about earlier. It's really important to use it properly. So in my opinion, it's how we use the fire testing is very important. We need to define clearly what the expectations are, first of all, from any fire test. If the test method finally chosen is appropriate for the case that we are working on. So even historically, if I may, if you look historically, this quest of, let's say, fire properties has been since the start of mankind. However, only recently we had a great advancement and progress technologically and scientifically to support and further enhance fire safety, especially with regard to fire testing. We had scientific discoveries like the first law of thermodynamics, heat transfer, testing capabilities, measurement equipment, data loggers, everything. So based on all this, we are in this position at the moment that we have a clear tool for using it when we talk about building fire safety. So at the moment, we all know about standardization committees probably. These fire testing committees, let's say, normally check and review the test method that we currently have every 5 years, if less in many cases, which means that we always try to take into account any scientific progress and advancement in order to consider better and more realistic, let's say, scenarios for fire testing. Even the so-called failed test, they provide really important insight for construction products and systems. So we need to keep an eye even for those and try to learn out of it. Only this way we can have considerable results in the future and try to maintain this level of safety in the future.
It's some interesting points there. Ashley, have you got any thoughts on this?
Yeah, I think exactly building on exactly what Tino said about, so obviously, there is information to be gleaned from any fire test, irrespective of where it passes or fails. I think one of the things that we do recognise is that I suppose a lot of fire testing is conducted by product system developers that are looking to get products to market, and they want their products to meet a certain standard. So to a certain extent, though, and totally understandably so, that a lot of what goes on, it becomes commercially sensitive. So I can imagine that there is stuff learned from testing that I suppose whoever the sponsor of a particular test was, they may get something out of it, whether good or bad, but it's just learning. But then obviously the opportunities for sharing that aren't there. They're not, they don't want to. I suppose it's the cost and effort and involvement in doing that test. That's that certain companies have kind of don't put that effort in, and obviously they perhaps understandably, I can get it, don't want to share. So I think it would be, and I think something that at NFCC we kind of push for more testing, but it needs we would like independent testing, and again it's a very expensive job, it's a very expensive task. It's not, you can't just do some testing. It's a lot more involved in that. But the more testing data can be shared, that actually that's kind of what's going to allow everybody to kind of move forward collectively. But the reasons why that doesn't happen are kind of understandable and obvious in what is by the time the testing comes around, by that point it's largely to a certain extent a commercial activity, and there's just the limitations around that.
Yeah. Tina, what's your thoughts on this from your perspective?
I think the supply chain is a massive issue, and the products you mentioned, obviously they're manufacturers. It's actually making sure that the manufacturers are I totally agree there with Ashley as far as the commercial side is concerned, but the life critical side is so important. And again, it's like, have they got product liability? Are they insuring? Have they got efficacy cover? This is the big thing that we're seeing. And efficacy is obviously failure to perform. So if a product is meant to actually do something, so sprinklers are the best example of that. If they're meant to actually go off and they fail to perform, then really the manufacturers should be taking responsibility. They should be having this efficacy cover. But I think a lot feel that actually, it wasn't my sprinkler, it was the installation. There's a lot the finger pointing that the test was done in XYZ conditions, but this has happened because of the installation. And I think that bit there, you see, and then obviously from the insurance perspective, we have obviously the pointing of fingers. Who is responsible? Well, ultimately, somebody has potentially lost their lives. So, the insurers, I'll be quite honest, and we'll go back to Mark's point, the tail on this at the moment, a lot of it will come back to the insurers through insurance. A lot of the companies may not even be in existence, X number of years, but ultimately the insurance was taken out. They can go back to them, but these sorts of what test was done, what was believed, how it should have been installed, some of this may be lost in the midst of time. So I don't know if that kind of helps, or can more conversations from that, more questions really. Sorry.
Yeah, definitely. You mentioned finger pointing, and we've seen that kind of web of finger pointing sadly in the Grenfell inquiry. Just briefly touching on that, and obviously fire testing has been one of the big things which has come out, and the poor ethics surrounding all of that. Without getting into the specifics or anything, but what lessons do you think we can draw? Ashley, perhaps this question for you to start off with. What lessons should we be drawing from what we've seen in that inquiry about fire testing? What should we be learning and taking forward from that?
I think obviously, as I said, and after I suppose some of the specifics that have been drawn out, I'm perhaps not too familiar with, but certainly around obviously a big focus on testing that's been conducted around external wall systems, and I suppose there's a real perhaps example around that. So obviously, I believe at some point they have full scale fire testing was done. Representative, a building, including those products where you set fire to it, and you can. There's a live test that mimics what might happen in a real life fire scenario, and from those tests, the starting point is a lot of tests are actually they've got two outcomes. They've got a pass and a fail. And actually, for a lot of people, that's all people that's the only bit they're interested in. And if you go down that line, that becomes quite a dangerous route. And that's one aspect. And that's one aspect. And then the other aspect is we talked about it already, but to what extent any of those tests are reflective of what actually ends up in the building at the end. If we start looking at an external wall system, there are so many components to that. There's the parts, it's how you fix it, and it's just unrealistic that there'll be a test that need an infinite number of tests with an infinite number of variables to reflect them all. So that's when you can start considering the parameters of that test. And then that obviously brings us into the world of desktop studies. I suppose looking at, we've got some test data that's not what we're looking at, but we start applying some sort of judgment on the information that we can get from that to determine whether something different is still safe. And that's obviously potentially very dangerous territory. There's so many unknowns, and that's a real specialism. And you can't cut corners there. It's a real detailed approach, very specialist. And I suppose that's where we've still got concerns to the extent that happens. And I said it's understandable why there will be times where it will be necessary, because there's simply the number of permutations. And if you're looking at, certainly you could be looking at testing of relatively, certain, lower risk aspects of building design. So where, for example, if we're looking at a system that's intended to be non-combustible, but where that system is made up of all the components are non-combustible, then actually do you need a test that says, do you need to do that extra test to bring all them together, when fundamentally you can appreciate that everything's gone into there is non-combustible? I mean, that's like the most simplistic example of that. But as soon as you start moving away from there, that's when it gets difficult, and we need to be careful.
Absolutely. Konstantinos, have you got any learnings from sort of post-Grenfell, the inquiry and so on, about what we should learn as an industry about kind of moving on from that?
I think the main outcome of this inquiry is the fact that fire testing, as Leia mentioned as well, has been performed. We had the testing data for different variants, for different materials, for different systems, which were actually used on Grenfell Tower. So the main thing here is to define whether all these test data were used properly, and how the installation was made on Grenfell, whether these actually cover details that had been tested or not, because finally it was a tragedy. So we need to know why this happened. Fire testing, as I mentioned earlier, is a great tool. The thing in Grenfell is that we had testing performed. We knew cases, failures, or anything else. But finally, all these products, somehow they ended up on Grenfell, on a specific installation, maybe workmanship. So all these companies and industry related, they should learn. We should learn as well as fire engineers this lesson, that we need to be very careful on what we finally install and how we install everything on a building, because desktop studies or fire tests, they can give you a lot of different opinions, a lot of different data, but how we use them is a different way. Ethics is one thing. Another thing I would like to mention here is competency of people. We need to raise the bar now, because maybe it's already late, but for many cases, but we need to do that now, because competency of professionals, not only fire engineers, but also people working in construction industry, needs to be raised. We need to have like more competent people working on, and so we can highlight issues on the design phase or even before delivering any building. It's really important. I think it has been mentioned anyway on rental inquiry multiple times. I'm quite sure you don't hear that first time from me, but we need to highlight that, and we need to make people aware of that. We need to do our best as professionals on every field, every industry related to construction and infrastructure. We need to raise the bar now.
Absolutely. There's certainly what you say about how we use test data is a very key point, isn't it? We've seen that sadly several times, but for sure, that kind of information, you might get a class on a product, but understanding the limits of that is quite important as well. I know we were approached by a glass manufacturer with a Class A certificate on a glass panel. Looks great, sounds great, especially given that laminate was inadvertently banned in balconies. However, when you start looking at the other aspects of it, even when you take the fire certificate and take it down to smaller sites, you realise that it becomes over 1%, and therefore, would it actually be a Class A product in a day-to-day balcony scenario where we've got smaller panels and thinner than what was actually tested? And it's a really important point about using those test datas and the test results for the right purpose, isn't it?
If I may, sorry, Nick, if I may add on this, since you mentioned about the testing certificates and this, I would like also to mention one issue that I've been facing a lot lately, that people within the industry actually mix the term classification with the term certification. These are two completely different things that we talk about. Some people think that having a classification report, it actually works as a certificate, which is not the case. It's not a declaration of performance, it's not a certificate, it's just a classification report. It has to serve a very specific purpose and does not mean that the product is certified or marked or anything else. Unfortunately, it's one of the main things that we try to make aware people of, that classification of a product or a system is completely different than certifying the product or the system. And this is commonly, let's say, mistaken by many people, unfortunately. It was just like, I would like to mention this example because it's something that we face all the time.
It's a really good point, and the word certification and conforms with regularly used, fully compliant with BS something another. It is a confusing area, isn't it? And it's almost more worrying than it is beneficial to see that in many cases. But Tina, what are your thoughts on this sort of aspect of misunderstanding information and testing, or perhaps misusing it, perhaps?
And you're absolutely right. It's easier for an insurer just to say no. They're not going to insure it if they don't understand it. So the fact of the test data and actually kind of having effectively an element of claims defense, because let's be realistic here, if it does go wrong, we are on claims defensibility, and the insurers will want to know that you will stand up in a court of law and explain the test data, why you made decisions or why companies made decisions at that point. And there will be a lot of challenges around third-party peer reviews, the challenges you did in environments, putting the product. And I think that's got to be fully appreciated now. Insurers will expect, you to stand by your products, would expect to stand by the testing, because they're insuring you based on that. That's what makes a good company stand out. That's what makes an insurer say, right, I believe in this product. I believe that the test that's been done, and these individuals, these companies know their products, like Sapphire, let's be absolutely honest, in a court of law, you absolutely could stand by why you did, why you put X, Y, Z in, what was the design, and why you decided on that project. And that's what you need. Accountability. Accountability is so important.
Absolutely. Mark, any thoughts?
Yeah, I think probably adding on to Tina's points, test data can't just be taken as correct. It has to be properly interrogated. And I think that was one of the issues, and one of the issues the industry has had. Konstantinos as well raised the point between certification and classification. I think, when architects are specifying materials, do they do the appropriate due diligence to make sure the materials they're specifying, although on the face of it seem to be able to achieve the requisite performance in relation to fire, have they been tested in that specific location? Have they been tested for that specific construction build-up? And I think the industry has got to get away from the view that it's always had, that it doesn't matter as long as that company's insured. If something goes wrong, we'll just go after their insurance. The government have made it quite clear, and the regulator have made it clear through creating the principal accountable person. The whole emphasis behind the Building Safety Act is our clients, freeholders, housing associations, have to take responsibility for the safety of their residents. Therefore, they have the responsibility to make sure, through appointing the right professionals, that the materials that are being proposed to be put into their buildings have been interrogated properly, and the test data that's been provided to justify those materials being used is correct and has been tested for that application. As Konstantinos has said, tests are extremely specific, and companies will hide behind specific tests and try and generalize them to make their products sound like they're a one-stop-all solution. Fire foam is a classic example. It's used throughout the industry, and because it says fire foam on it, people were squirting it everywhere to try and solve every issue known to man. But actually, when you interrogate the properties and the test data, it's actually only really suitable for very specific applications. So that's really my point, is we have to take responsibility, our clients have to take responsibility and interrogate test data much more thoroughly to make sure that they are happy that it is to the adequate level to provide the right level of safety for their residents in their building.
That's a good point, because it's not just about any one person's responsibility, it's about the chain of responsibility, isn't it? You mentioned earlier on about the golden thread. It's about each company in that process knowing and taking the ethical approach about that piece. But you mentioned about fire testing. Given that fire tests are being conducted in a controlled environment, do you think they actually simulate the actual real world fire scenarios? I'm particularly thinking cladding systems and attached buildings and so on. But what are your thoughts on that, Mark?
I think it's the best we can do. No one's going to build a high-rise building and set fire to it. Well, no one yet has done that. So I think it's the best we can achieve. The fire industry is interesting at the moment because it's all about the minute details. We look at specific test data, we look at components together, and actually, I think there needs to be a much more practical, pragmatic view on fire. If we are designing buildings now with sort of limited to no combustible components within that building, what is the risk? And if we have test data in a controlled environment, yes, it's not going to be able to replicate the exact environment that building will find itself in, but is it adequate to satisfy the freeholder that the risk has been reduced as much as possible? I think it has to be, because there's nothing else we can do. I mean, ultimately, the responsibility is on the principal accountable person, and they have to be satisfied that they've done everything they can to deem that building safe. So, it's never going to be exactly the scenario, but I don't see any other way of providing that data. I think it's as robust as we can be, basically.
Konstantinos, any thoughts on this?
I cannot agree more with Mark. It's the best. It's what we have at the moment. This is what it drives mainly our knowledge on many materials and systems. And this is what we need to work on. To maybe, are they the best solution? Do they cover everything? Probably not, I would say. But it doesn't, they don't need to be honest. They don't need to, because we need to have basic understanding of the physics and the behavior of materials and structures in fire. We do not need to cover all potential scenarios, every fire scenario or every risk, because this is what engineering and science does. We can have the test data, we can provide specific test scenarios, get the results and work on them after. We have like plenty other methods also to account for different cases if we want to. But I mean, for example, empirical correlations, CFD simulations, zone modeling, other tools, softwares that have been also been developed in the latest years. But fire test is a basic scenario that we can work on. We can have, we don't need to have like all the scenarios as I mentioned. We can make necessary assumptions on the design phase, but all this, they need to be done by trained and competent people. That's my input on this. We can always argue about the sufficiency of test methods. We can always argue about whether actually they are great or not. But I think this is what we have at the moment, and we need to work based on that. Make it better, yes, obviously, but also have it as a base for many scenarios.
Yeah, so it sounds like there's fairly general agreement on that. Ashley, yeah, I'm just kind of looking at some of the exemptions and things like that. We've seen use in some tests of getting materials below a certain percentage so that they fall within the European Commission's Directive of 1996 and so on. What are your thoughts about kind of almost look of these tests, which are almost looking for a pass by getting things within a certain parameter or field? What do you think that reflects a real life scenario, or what are your thoughts on this?
Well, I suppose that goes back to the point. I think you know, for some people, the purpose of the test is to the test doesn't exist for any other reason than to try and pass that test. That's the only thing I'm interested in, and I think evidence of products that developed and gone through tests that will fail one test. Like you just constantly refine the product, change that product until you get a product that finally does pass the test, and then everybody's happy, or not. So then obviously the company they've got their product. So that's and that's really it's working to these absolute, in effect, what we're working there is absolute minimum requirements. It's actually not really understanding what our products are doing. It's that it's not the right approach to just playing with the mix, trying to get that right amount just to kind of creep over the line of safety. It's not the right way to do things.
Tina, it looks like you want to say something.
No, I just that's the problem the insurance industry see. I'll be honest with you, this is the retraction of insurance cover because that's what they've seen. That the actual, there has been, shall we say, fudging to for a commercial, not for a life safety. And as far as insurers are concerned, we go right, and I said earlier, we go right across the piece from the life safety, the asset, even to the directors and officers, as Mark was saying earlier. The regulator will go after individuals now, and they'll be personally accountable. Quite rightly so. Let's be really clear. They're absolutely. But how do we get this best practice, and how do we get the competency? How do we almost get that overarching? I mean, I'm very passionate about, and this, Nick, you've heard them before, Clerk Works. I'm very passionate about the fact of actually that overarching responsibility, that person to challenge constructively with knowledge, with expertise, with experience that is needed, and they're just not there, unfortunately. Yeah,
absolutely. And even in the absence of them, it should be an obligation on certainly any product manufacturer to be able to challenge those questions and those queries of choices, both in terms of the marketplace making choices, but also actually the choices we may be making internally within the company as well. Any thoughts on this, Mark, from a point of view of these products kind of transitioning through to the actual sites?
Yeah, I think again, I'm going to expand on one of Tina's points about the clerk of works. I think that's a really good point. And actually, what we're seeing, which is really positive with the industry, is I think, you know, having now been bitten by this, contractors and developers are understanding that actually, can you rely on the clerk of works? Can you rely on building control once they've signed it off to then sort of never worry about it again? So the systems that contractors and developers are putting in place to record what they've installed, to provide that golden thread of information, is so much more robust than it was even 2 years ago. There are companies out there now that will record literally everything that goes into the building, to the point where you can sort of, within a model, peel it back like an onion, layer upon layer, so you can see every component. And 2 years ago, when I was talking to clients, oh no, you know, that sounds a bit expensive, we don't really need that. Now it's written into their employees' requirements, because they realise that it's not a wish list anymore. This is a requirement to make sure that if you're ever asked a question, you can just provide that golden thread of information. And that, in conjunction with the clerk of works, I mean, the problem with the clerk of works always has been is they can't see everything. And you get really good clerk of works who will work with you and offer solutions, and you get really bad clerk of works who sort of just sit behind you writing notes, and then you get a tap on the shoulder from the site manager saying, take that down and rebuild it. So I think the golden thread option really is the best way to go, and I'm really pleased to say that a lot of the house builders and developers who work, in fact all of them, have all now got their own quality managers on site, who their single job is to digitally record everything that happens. So I think the industry is learning very quickly, and as always, it's because of the financial impact that is happening at the moment in regards to the retrospective building fire safety works that are going on at the moment, that through Mr. Gove's contractor's pledge and contract is hitting them directly in the pocket. So it's forced a more robust process, which is fantastic.
Konstantinos, any thoughts on this particular topic? The future?
I think we need to keep in mind that future is already here, to be honest, and we cannot just react, but take the relevant steps, let's say, in advance. I must mention that the primary goals of any regulation and guidance we have with regard to fire safety is very similar for the last 50-60 years, more or less, I would say. So we need, first of all, the primary goal is to ensure life safety, and then property and environmental protection. This has been the same since maybe 1960s. So we should be definitely reviewing, trying to confirm current infrastructure and buildings, so we can and check whether they still serve the purpose, and make any amendments necessary towards this for the current infrastructure that we have. Now, obviously, testing is one of the main, let's say, tools that we have on that. So obviously we have experience, and we should be expecting, let's say, great advancement in new materials, innovative structures. So we should be try and keep up to date all the testing methods, try to elaborate further on fire testing, and obviously we need to help ourselves towards that, to help ourselves to understand the physics behind all these new materials and the future, let's say, challenges we should be facing.
Yes, some interesting points. Tina, what's your thoughts on this?
Yeah, absolutely. I mean, the way forward, you know, go back to Mark's point there, is from the insurance perspective, prove what you're doing. You know, so you've got the schematics, you've got the golden thread of the building. Use that when you're going in to negotiate all manner of insurance. Insurance, obviously, let's be realistic, from an asset point of view, fire is just one risk. All right, so you know, when we talk about fire from the insurance perspective, you will hear that's just one risk. Yes, okay, the knock-on effect is the life, it's the building itself, but they'll obviously be worried about flooding, earthquake, etc., they're right across the piece. But I do agree with Mark, when you've actually got this good data, this good information about the building, then it should be transported and given like a Bible. You know, as the intention is, it should be a Bible of every business, every building. And that is actually very powerful when you sit in front of an insurance company and say, I have a portfolio of 60 properties, and here is the blueprint. Here is all this technology that should be used to reduce, you know, the risk, premiums, you know, and then defensibility. You know, that really is those three pillars as far as the insurance is concerned.
So it'd be an oversight if we didn't mention about the whole cost of testing. Obviously, it'd be great to be able to test everything, but the reality is it costs money and it takes time to do and so on. And Mark gave us a great example at the beginning of where it's delaying properties and causing knock-on effects. But how much, perhaps Mark, if you initially answer this one, but how much influence do you think cost has on the frequency at which testing is done? And is it a barrier?
I think it probably was. Now I think when you look at the cost of retrospectively remediating a building and that cost, I think actually it's considered a bit of a drop in the ocean. And there aren't many situations where contractors haven't asked to do a full-scale test of the wall build-up, for example, and I'm talking retrospectively here, where we found issues in elevations with limited cavity barrier installation, or no cavity closers around windows. Rather than just reinstate those cavity barriers, the contractor says, well, can we do an 84144 test to understand actually what risk that presents? And that's the sort of line the government are pushing us down with PAS. Is compliance is one issue, but really what they're interested in is risk to life. And that's probably not what Tina wants to hear, because insurers are also incredibly worried about the insurable risk to their asset. But that's, that for me is where the whole education piece for insurers comes in. And we've spoken to insurers as well, Tina. We've spoken to a number of insurers. And once they understand that, in effect, if you're saying something presents a low risk to life, you're also reducing the risk to the asset, although PAS doesn't necessarily talk directly about the risk of the asset. They understand it more. But yeah, to go back to your point, I've sort of gone off piece a little bit there. I don't think there is any issues around cost because of the potential cost in terms of liability if they get it wrong. And I think now that is prevalent, developers and contractors understand that. And it's a no-brainer, really. And once you've got that test data, you own it. And the other important thing is that construction is by its nature, in most cases, standardized. So why wouldn't a house builder go out and get all of their standard construction details tested? Because once they own that data, they've only got to do it once. And there aren't many house builders that are changing their construction details year on year, because it's just not cost effective to do that. It takes retraining of staff, different subcontractors, different skill sets. Standardization of construction types means you can be more efficient and control quality. It's the whole reason why MMC is trying to sort of get a foothold in the market, because you can standardize details and produce things, in a more controlled manner. But no, I don't think it's an issue. Not anymore anyway. Potentially in the past, but not anymore.
Ashley, you mentioned at the beginning you've been involved in ADB and so on. We've obviously seen lots of new things. We've seen lots of advice those. We've seen them amalgamated again. We've seen various different standards and ADB itself obviously being adapted and adjusted and so on. What are your thoughts on the situation with getting a balance right between kind of a focus on new build versus a focus on existing buildings? Do you think that balance is right? Do you think there's more needed in either of those?
I think yes, I think there is. I think the recognition that, I suppose, the easy bit is to try and get stuff right from the start. So that's where that's almost the easy fix, and that's why we see those changes. And that I think we support a lot of those changes. But I totally agree that there is a legacy issue that's to a certain extent, being ignored. I mean, we are fortunate, I suppose, that the fire safety order, obviously the primary fire safety legislation, that does allow us to, requires buildings to be safe, irrespective of when it was built. So obviously there's a judgment on and a perception of what safe looks like in any one building. So we've certainly, those powers to do that exist. But irrespective of all that, I think, some of these recommendations that we are seeing coming through as requirements for new builds, absolutely, as fire services, we would like to see them apply to existing buildings. And I think, a very obvious one would be, the change in, the change in height thresholds for the requirements of sprinklers. It's now down to 11 meters. However, we could still have 30-meter buildings that haven't got them, and all the issues that might be associated with that building in terms of, a single staircase, what may or may not be on the outside. Well, that doesn't need sprinklers, and I'm not sure how we address that in terms of which bit of legislation that would fall under. But I absolutely agree there is a real risk of, let's sort the new stuff out, but we're forgetting about the legacy issues. And yeah, I don't know what the plan is, but it is a concern, certainly.
Mark, any thoughts on this?
Yeah, I think, just touch on what Ashley said there. I think, although I agree in a perfect world, Ashley, we'd make everything existing compliant to building regulations. Unfortunately, the reality is it's not economically feasible. And when we first started this journey in fire safety, retrospective fire safety, when we had the consolidated advice note, the advice from the government was remove everything combustible and start again. And I think they very quickly became aware that it meant that, we had fire safety programs that were going into 20, 30 years by the time that, companies such as ourselves had gone and RAG assessed, housing association stock and freeholder stock, and RAG assessed and put costs to the potential remedial works. It was running into hundreds of millions of pounds worth of work. Then as a reaction to that, PAS was then created, and we worked hard as others did with MHCLG at the time and DLUC and Homes England to produce a risk assessment which would take a pragmatic, practical view. Now, sprinklers, yes, are a great option in some circumstances, but what we've got to be careful of is that we don't look at fire as a single component within a building. The building has so many other contributing factors that have to integrate together. And we recommend sprinklers where we can, but often we get pushback from insurers saying, well, actually, you know what, the risk of escape of water is just as bad to us as the risk to fire. So, and we have to take that into consideration. We have to take consideration, the height of the building. Are we going to have to sell a flat to put an intermediate pumping station in to get this, because no one wants cold water storage tanks, or the roof hasn't been designed to take loading. There's so many other factors that come into it that actually it becomes more cost effective just to do the remedial works to the external wall. So I think we have to be careful when we talk about compliance to building regulations, and we have to, remember that ADB is guidance and can be superseded by a fire engineered design. But that sort of brings us full circle into the fact that if you are going to go down a fire engineered design route, that test data backing up that strategy has to be robust, and it has to be properly interrogated and specific for what you're proposing.
Mark, you make a really good point there, particularly for us in the many installs out there which use laminate glass. That was a kind of safety move, if you like, away from monolithic glass, which is ultimately is more dangerous in the opinion of most of the industry. But obviously, laminate glass is not a Class A product. Monolithic, would it be a good move if people moved away from a fire safety point of view to say, get rid of that and put in monolithic glass? Absolutely not. It'd be increasing the danger overall. So you make a pretty valid point there, Mark, on that particular bit. piece. But I think the time's come for us to start wrapping this up now. I'm going to go around and get some key takeaway from each of you, if that's okay. Tina, perhaps if you kick us off on that.
Yeah, I mean, mine is obviously traceability. It's traceability of the products. It's traceability of obviously having those records, the test data, and also, you know, knowing who you're engaging with from a manufacturing point of view, that they do have insurance, they have adequate insurance, they have correct limits. That's what I would be my takeaway.
And Konstantinos.
Yeah. On a fire engineering perspective, I would like to highlight the fact that fire testing is a great tool that we have at the moment. How we use it is another issue, and that's why we need to work on that. Obviously, all this information that we can gather for buildings, for current buildings or for future buildings, is it's something great. We need to incorporate that into our design. However, finally, what we need to do is to make sure that we have design and methodology for ensuring life safety. That's a primary goal on a fire engineering perspective. Obviously, cost, insurance, policy making, all of these things are elaborated, but finally we need to look at this on this primary goal we have.
Thank you. And Mark?
Yeah, I think what Tina said there is extremely valid. I'd like to sort of expand on that again and say that once you understand that traceability, your accountability doesn't end there. We can't afford to go back to the old ways of just relying on PI cover. We have to understand that we are all responsible for fire safety, and that once we've got that test data, it has to be properly interrogated technically to make sure that we as a project team are happy that it represents the correct information for the application, and we're not just relying on the fact that whoever's providing it's got the requisite insurance if it all goes wrong.
Yeah, sure. Ashley?
Just echoing an empty remark that that's what the fire testing. That's just one part of the that's one piece of the puzzle. It's understanding what that means. It's about competence to apply that test. Is it appropriate for the situation that it has been? Ultimately, it's going to it's going to end up in.
Absolutely. So, from my point of view, I think some of the points that struck me during it probably come down to four, or some of the points you mentioned, Konstantinos, was firstly understanding the expectations, and that not just being a pass, it may be a learning opportunity and so on. Looking at the suitability for the scenario, understanding the kind of progress and innovation and industry progress generally, but then also really what crowns it all is about how we use that data to improve the industry or our products at large. I'd like to thank all the panel for their input today. Thank you very much for that. We will now be heading back to have a look at the fire test. If you'd like to join any of the other live streams in our ResiBuild Roadshow, you can join and sign up at www.resi.build. That's resi.build. Thank you very much, everyone, for your contribution today.
Thank you.
So thank you everyone for joining us for the panel discussion. We trust you enjoyed that aspect of it, and you may have noticed the test running live in the background as well. We're back here now in the lab again. We'll be looking in a bit more detail about what's going on in a second with a few different camera views. In the meantime, we've just got a number more questions in. Thank you everyone for those of you who have contributed. You can see several different names there. Continue asking questions. If you haven't been able to log on yet to ask a question, www.sli.do, and the hashtag is ASKAsk. So looking at some of the questions, it looks like we've had one panel discussion question for Tina, which we didn't note at the time. Sorry, we weren't looking at the Slido questions during the panel discussion there. So the question is about insurance. We will put that to Tina. Next question from Rob. Thank you, Rob. Does Stubguard have any limitations of use, e.g. scenarios or build-up? There's a brilliant question there. Yes, is the simple answer. The limitation of use, though, is really about what people are happy with from a design team aspect, and that's not really a question for Sapphire. That is for the specification, the client, the fire engineers and all the people involved in that project. So we've seen in the Grenfell inquiry the importance of everyone being aligned on fire safety strategies and so on, and the importance of integration between those and being happy with scenarios and so on. In terms of the actual direct answers to that question, Stubguard has been tested in numerous different scenarios. Now, it's understandable that in this particular case, we're just trying to keep that really simple for ease of building knowledge and understanding. Now, we've got one scenario here. We're testing it with one product manufacturer, one integration, and in this particular case, a closed state cavity. There are limitations on Stubguard. They are referenced in our Stubguard literature, and we're quite clear and transparent about what those are. One of the point you've made, Rob, about scenarios or build-up is a good one. In terms of scenarios, what we tend to find is that actually there's a lot more options available with Stubguard because of the fact that it's very, very small and tight fitting to the arm. What that means is that you don't have a big build-up of a balcony, you don't have it conflicting in that spandrel zone where you've got a lot going on in a very small space. Some of the other scenarios we've seen people use have had to have a 203 I-beam, quite possibly because of the weight of the balcony on the outside. Obviously we used an aluminium balcony, so it's quite lightweight. And the other scenarios we've seen is boarding around and then having mineral wool and so on wrapped around that. This particular case, the Stubguard is very close fitting, and we'll see that in the results in a second. So we've also had a question, another question it looks like for Tina. So again, we'll put that to Tina and we'll try and come back before the end of this live stream. Can we get an update on the results and what they mean? Absolutely, I'll give you an update in a second. What's happening inside the furnace? Good question. I suspect there's a lot of heat in there. The current temperature in the furnace is just over 1,000 degrees. There is a small peephole, but it's not really enough to get a camera to take photos of it there. But we did have a look at approximately about 10 minutes ago. Some of the fireproof boarding at the top of the furnace was coming down slightly. That doesn't affect the test results as expected in these kind of scenarios. But in essence, the temperature is being held at a fairly sustained temperature now. So if you think about this in kind of, if you draw an analogy to an aeroplane taking off, the aeroplane will be accelerating height-wise, and altitude will be going up and up and up, and then it's a fairly sustained period of time, similar sort of curve to what we're seeing here, quite a hockey stick curve, if you like. I think that's all the questions for now. Oh, sorry, missed one. What Stubguard cost? Would Stubguard cost my project more money, and does it have any benefits, e.g. sustainability? It depends if you're talking direct costs. Obviously, it's an additional element to the Sapphire package. Normally, that would be fitted by the people doing all the fireproofing and so on. We would supply that, and it'd be free issued directly by the developer to that company. So there's a cost of that. If you're talking about a direct cost or a cost increase, that's two different aspects, because Stubguard is often more cost effective than the solutions of boxing around working out those. But a real big emphasis here that you need to make sure that all the project team and that those involved in the specification and design are happy with it, from the fire engineer through to any other party involved in that process. That is a really important thing. And looking at the other options and solutions, Stubguard is one which we believe is a very good solution, and we'll see the test results fairly shortly now. In fact, we've just gone over the 2-hour mark, and we'll be back to you on the results in a second. Thank you very much, and I'll give you a result update in a second once we've just worked out what's going on. So here we are at 2 minutes 11 into the test. The test is actually going to 2 minutes 12, which is a 10% margin, which is standard practice for this particular BSEN test. Now, what we're seeing here, the temperature inside the furnace, as I mentioned earlier, is over 1,000 degrees. That will be coming down shortly after we hit the 12-minute past the 2-hour mark. The sensors continue to record, and this is what we're seeing on these lines here. There's a selection of bits of information on each one of those sensors on both the cavity barrier and the Stubguard one here. What we've got here is after the 2-hour mark, the peak temperature, all of them are under 100 degrees at that point. With the cavity barrier, they're actually significantly higher than what the Stubguard are here. So you've got one which is raised here, but all of these are averaging around the 80 to 90 here, whereas the Stubguard is starting about 55 and up. So that's kind of where we're at the moment. We'll be talking a bit more about the finished results in a second. Looks like we've just hit the 2 hours and 12-minute mark. So we've had a couple more questions through. Thank you for those of you who have asked. We're going to have a little look at the results again in a second once we understand a bit more. At the moment, the furnace is just cooling down. The temperature, when it gets to the right level, they're going to remove the door so we can see what's happening inside. Obviously, a very intense heat at the moment there, although we can see here it's already dropped by nearly 400 degrees. In terms of the two questions which have just come in, the first one, can you provide a diagram of the system, if so, in use, so we can better understand what's being tested? Good question. So this is, as I mentioned at the beginning, the diagram is the Stubguard one. This pictures can be seen on the Sapphire Balconies website, which is www.balconies.global. And this product is called Stubguard. What we've got here is a diagram there showing a section cut away. What we're seeing here is a view from above the furnace, and that is a bunch of sensors there, which is what we've been testing. This is what the inside looked like before the test began. We'll see what that looks like in a second. And the I-beam there has got a number of sensors on it, which is before. This is the stub and arm there, which is where this stub is actually guarding. So we've got the sensors on the I-beams which have been testing. All of those, as I mentioned earlier, have been below the 100-degree mark, which is considerably less than what could have been an allowable temperature. We started off with a temperature of 16 degrees in this test lab. The temperature can rise 180 degrees within a 2-hour period. That would have taken us to 196 degrees to just under 200. So we're less than half what that could have been the case of. We'll close off shortly, but in the meantime, we've just got one more question from Paul. Thank you, Paul. What are we trying to achieve? Now, the point and purpose of doing this test really is about increasing knowledge and competency of the industry at large. What we're testing here is a different scenario to the ones we've tested previously. We've done lots and lots of different tests in different labs with different configurations and integrations with the Stubguard. This is testing the new ultra-low carbon balcony anchor, which is a slightly thicker version. It's a complete class A1. It's called our ACE anchor. And this is where you've got the integration with a cavity barrier, which is what you can see at the end there, with a Stubguard. And we're testing the amount of temperature, making sure that the insulation and the integrity is good after a 2-hour period. So we'll look a bit more inside the furnace once it's cooled down enough for them to be able to open the doors. But thank you for joining us, and we'll show you the last part of that shortly. So thank you very much for joining us today. On behalf of Sapphire and ResiBuild and Efectis, I'd like to say a very warm thank you for everyone who's been contributing, both in terms of the Efectis test lab, but also in terms of panelists. We'll be shortly opening up this furnace, by which time we won't be able to get anywhere close. So it's a goodbye from us. If you haven't got any other questions which you would like answered, please do put them in the Slido poll or comment if you're watching it from social media, and we'll try and answer as many of those afterwards as we can. But again, thank you very much for joining us today on this live stream from the ResiBuild Roadshow here in Belfast, UK.